Welcome back to Ellias Academy, day 40. This week we're going to be talking exclusively about similar triangles, and particularly overlapping similar triangles, where you're going to have a smaller triangle and then a larger triangle that was like formed by a dilation at that top point P. And you can see how the red overlaps with the blue. So that's kind of the triangles we're going to be talking about today. And I, right from the start, can tell that they're similar, even though they don't tell me. I can infer it, I can deduce it from this this statement here, that RS, the base of this smaller red triangle, they're telling me it's parallel to the base of that larger overlapping triangle. And that can only happen when triangles are dilated, because corresponding sides will be parallel. So now that I know that they're similar, I know this problem will be solved with a proportion. I'll be making like a ratio equal to a ratio using corresponding parts. So let's take what they give us and put it into our diagram. So they tell me PR is 12. They also tell us PS is 21. And that right off the bat is one of our triangles. And I'm just going to put that information back in. This is 12 and 21. Okay. They also tell us that RQ from here to here, this little piece, which noticeably isn't a side. You see how that 12 belonged to a side of a triangle? That RQ, it's not a side of any triangle. It's a piece of a side. That piece is 8. So if I were to try and figure out this entire blue triangle, I know that entire side is the sum of that red piece. This entire blue side is the sum of the red piece plus the green piece. So this entire blue side would be 20. And what they want us to find is the side of PT, and that's the entire length of the opposite side. That entire length is what we're looking for from P all the way to T. So we're trying to figure that out. I'm going to call that X. So I'm going to erase like some extraneous stuff here. All we need to see is that we now know that this entire side is 20, right? That came from 12 and 8. And we're looking for this entire side over here, which we're going to call X. So we're going to make a proportion now. We're going to fill it in, and we're going to fill in corresponding pieces. Oops. And the corresponding pieces we're going to use is, let's start with 20. I'm going to put that here, and I'm going to divide that by the corresponding side in my similar triangle, 12. And then if I start with something from the bigger triangle, like right here, this was big divided by little, my other ratio has to follow the same suit. It's got to be something from the big divided by the corresponding piece from the little. So I'm going to take the X from the big, and that corresponds to this 21. And boom, there is my proportion. There's a couple different ways you can make the proportions. If you have something different, go ahead and solve it, and just make sure we have the same X value at the end, or at least the same solution for PT. Our X values may change as we move on. So let's go ahead and solve this proportion. We're going to cross multiply, or butterfly multiply, if I'm trying to stay true to my word. 20 times 21. Boom. Get out your calculators. 420. And then 12x. Divide both sides by 12. And x will equal whatever that quotient is. 420 divided by 12, 35. Whenever you get an x value, don't just box it off and be like, oh, I'm done. Substitute back into your diagram. Okay, this entire side is 35. Is that what they asked me, the length from P to T? Yeah, they did. So I'm going to make a statement and just say the length of PT is, in fact, 35, and box that off. You can expect more stuff like this for the rest of the 9 problems. I'll see you there.